Hey everyone, welcome back. Today we're doing day 7 arrays, and like the name of this question suggests, we'll be learning about the array data structure. So for this task, we're given an array A of n integers, and we have to print all elements in this array in reverse order as a single line of space-separated numbers. So what this means is, if you have an array consisting of 1, 2, 3, and 4, then we'll be printing this same array but in reverse fashion, 4, 3, 2, and 1. And notice that each integer is separated by one space. So the input looks like this. The first line consists of the number of integers that will be inside this array. And the second line is the array itself, but in string format, separated by a single space. Luckily for us, HackerRank is nice to implement the boilerplates for reading in the first line as n. And in this case, how they do it is just using the same tactic as we saw in the previous challenges. We wrap in the line using getLine into a temporary string variable. We trim it of white spaces on the left and right and converted that into an integer. And for the second line, they did the same thing. We wrap in the line into a string, and on top of that, HackerRank even implemented this split function that converts this string into a vectors of string. They're splitting it by the white space. And afterwards, HackerRank iterated through every single string inside this temporary array and convert that into an integer before passing it into a second vector of integers on line 23. So with that, we understand how the input-output logic works, and hopefully this will be helpful for subsequent questions, but we can get started on solving this question now. So there are two tactics that we can use for this question. The first tactic will be to iterate just all the elements but from right to left instead, and this will give us the output of just printing the array in reverse. And let's get started with that first approach. So to do this, we can use a simple for loop to keep track of the current index. And in this case, the current index will just be size minus 1, where size is the current size of the array. So this will just be size minus 1. For the conditions for the for loop, we will continue to do this as long as index is more than or equals to 0. And after every iteration, we will move the index towards the left by decrementing it. And for every single character that we have, we'll be printing out the index at the character at this current index. And because we need a space after every single character, we'll be doing a cout for a space character as well. But we only want to do this if the current character is not the final character to be printed. So we'll just do a simple check for whether if index is not equals to 0, because 0 will be our final index. And if that's the case, we'll print out an empty space, and once we're done, we can terminate that with an end line character over here. So let's run this against some sample test cases. This passed, and let's run it against all the other test cases for this question. Taking some time. Should have paid my internet bills, but taking some time. Okay, let's see. Okay, it works, but at this point of time, this is pretty much the most efficient way to solve this question because we only have to do this in one pass. So there's no need for us to iterate through this same array twice or something. So the second method of doing this would be less efficient compared to this, but it would let us have the chance to segue to how we can reverse an array, and that is exactly the second approach. The second approach is to reverse the array first before you print it from left to right. So in this case, reversing takes about half a linear scan. So that's one additional half a linear scan of computations, and you have to do one full linear scan to print out everything again. So the second method is actually more tedious and less efficient compared to the first approach. But let's do it anyway for the sake of completeness and also to give us an excuse to implement a reverse function. So to do that, let's define a simple function that returns a vector of integers. Let's define a reverse function that takes in a const of a vector of integer. And in this case, this will take in the reference of the input vector. And this function will be returning a copy of the reversed array. So the input vector will not be edited. That's why we said that this input is a constant. So let's copy this function signature and start defining it on line 43. So since we don't need this, let's delete this first approach that we used earlier. And let's start defining reversing the array. So reversing the array consists of two steps. The first step is to make a copy of the vector, which we will call reversed array. Let's just call this reverse vector, sorry. And let's just assign this to input vector. This would have the net effect of assigning a copy of input vector to reverse vector. And the next thing is to just use two pointers where your left pointer is pointing at the start of the array and your right pointer is pointing at the end of the array. And what we do is we swap these two numbers and we advance both the left and the right pointer towards the center. So this will stop once the left pointer reaches the center of the array. So to do that, we can define a for loop. Before we start, let's just have a simple size convenience variable that keeps track of the current reverse vector's size. This will be helpful for keeping track of the termination condition for the for loop. So let's define the left pointer inside this for loop. The termination condition, or rather the execution, the condition that must be met as long as these for loops keep iterating is for left to be less than size divided by 2. In other words, as long as the left pointer is not at the center of the array. And after every single iteration, we want to move the left pointer towards the center, so we will increment it. So the swapping logic is this classic logic over here. The temporary variable will keep track of the reversed vector's value at the left pointer here. Let's define a right pointer as well. And the right pointer, this right pointer over here would just be size minus 1 because a vector is 0 indexed. So the final index is really size minus 1. And on top of that, we want to minus this by left because if left moves towards the right, we also want the right pointer to move towards the left by that same amount. So this will be right. So now that we assign the left value to 10, we can override reverse vector's left to be equals to reversed vector right. And now we can assign reverse vector right to temp. So this has the net effect of swapping the left and right pointers. And once we're done, the left pointer will continue to advance and it will just perform the swap till it reaches the center. So at this point on line 45, we successfully obtain the reversed vector. And with that, we can finally go ahead with getting our copy of reverse vector over here by just passing the array on line 23 into this function that we just implemented. And once we're done, we can just iterate this from left to right again, I less than size, I plus plus, and we just do the same logic of printing out the reverse vectors at I. And if, in this case, if I is not equals to size minus 1, in other words, that current character that we're looking at is not the final character, then we will do the additional step of printing out that new space. And that's pretty much it for the second approach. Let's run this. This passes the test cases. Yep, I definitely need to pay my internet bills. My internet bills, yes. Okay, looks great. And at this point of time, we have successfully completed the second approach of reversing the vector. So this is the second approach. I wouldn't recommend this in a technical interview because you're adding one additional layer of complexity of implementing this reverse method. But I hope that this was helpful to you to know that you can solve this question in two methods. There might be more, but I'm pretty sure that the other methods are quite similar to what we have explored today. So with that, that's pretty much the end of this video. If you really like this video and you like this demonstration and you felt that this has brought value to you, please consider giving us a like and subscribe. That will pay my internet bills. And with that, thank you so much for watching, and we will see you in the next episode.